Right, so in order to provide optimum signal quality and adequate voltage level for further signal processing, the amplifier has to provide sufficient gain and needs to maintain the best possible signal to noise ratio. So the presence of high level interference signals not only deteriorates the quality of the physiological signals, but also restrict the design of the biopotential amplifier. The electrode half cell potential, for example, limit the gain factors of the first amplifier stage, since the amplitude can be several order of magnitude larger than the amplitude of physiological signals. To prevent the amplifier from going into saturation, this component has to be eliminated before the required gain can be provided for the physiological signals. Okay, so that's why when we use the first stage amplifier, the amplification is not much as compared to the other stage of the amplification, because we need to consider this kind of limitation, electrode half cell potentials that have several order of magnitude larger than the amplitude of our physiological signals of interest. Interference can come from the contact between the electrodes and biological tissues. So it is actually a critical point in measurement of biopotential. So source of interference are subjected to changes due to relative movement of electrodes and tissue. So it can have electrode offset potential, and it also have electrode to tissue impedance interference. So these two interference signals create the motion artifacts. Yeah? Motion artifacts. So that's why when we measure, we want the patient to be relaxed as possible and minimize any possible movement, so that we don't want to have this kind of interference. Okay. See, the motion artifacts is the movement result in skin deformation, which changes the impedance and capacitance of the skin around the electrode site. So when we move, it will cause skin deformation. Skin deformation, and this skin deformation will change the impedance and capacitance of the skin around the electrode sites. So a shift in the baseline of the biosignal that is similar to a DC offset of the signal, and the change can be abrupt. So we don't want to have this kind of artifacts, so that this artifact can deteriorate our signals. Okay. Next one is these motion artifacts can be minimized by using a high input impedance preamp. That's why in the earlier slides we stress out the importance of having high input impedance preamp, and then usage of non-polarized electrodes, because non-polarized electrodes will reduce the effect of baseline or wandering, and use of electrode gel to reduce the impedance at the measurement sites. Okay, and we can use the wires connecting cables and electrodes that can reduce the motion artifact and external electromagnetic field and noises by use the twisted pair cables, shielded wires, and input guardings. Okay, this is example of circuit that provide the input guarding. So this is the amplifier. So this is the amplifier component, and this is the input guarding component. The common mode input impedance as well as the CMRR of an amplifier can be greatly increased by guiding the input circuit. So the common mode signals can be obtained by two averaging resistors connected between the output of the two input op amps. This one. So this is the averaging resistors. So the buffered common mode signal at the output of op amp can be used here, can be used as a guide voltage to reduce the effects of cable capacitance and leakage. Okay, so when it detects some common mode signals, so it will give back to this op amp, and we give back to this input. We give back to the input so that it will cancel out each other. Then we have electrode contact noise. So frequently encountered when dealing with the patients who are diaphoretic. What does it mean by diaphoretic? Is actually heavily sweating. Heavily sweating. The patients usually have more sweat than the others. Okay, because when they have more sweat, the electrode simply will not stick to the patient's body, and it will create the electrode contact noise. And this type of artifact is also can be seen when placing the electrodes over hair. This will be rapid and random baseline transition of the signals. The transition decay back to the baseline. So usually when we do the EEG signal measurement, so blue roma tak ada masalah sangat kan. But when we do the EEG measurement, we stick out the electrodes to the hair, to the head. So the hair will have this kind of artifacts. Next one, we can have a breathing artifact. So the respiration can cause the signal baseline to move with the waveform of the respiration. So when we do the usually ECG measurement, so that's why we want the patient to be sit at a comfortable position, and she or he must be relaxed and breathing in normal manners, so that we can reduce the breathing artifacts. Other interference can also be caused by the environment, with many electrical systems which produce strong electrical and magnetic fields, in which generate 50 Hz power line frequency and its harmonic and high frequency EMF. In hospitals, usually there are many equipments in one room, right? So that's why when we design electrical medical devices, we have to take into account the EMF. The EMF. So the device must be able to protect from the EMF of surrounding signals. Okay, if unwanted RF signals are transmitting at the same carrier frequency as a medical radio signals in the hospital environment, it can cause the medical signal to be corrupted or interrupted. So we don't want this. At power line frequency, the electric and magnetic component of the interference field can be considered separately. So that's why when we have this at the hospital, they will have two power supply. One is the hospital power line frequency, and the other one is not normal power line frequency. Normal power, source power. Okay, so that they will have different. There will be isolation between the normal use for devices, and as well as the other one is used for medical devices. Right? This is examples of telephone radiation taken latest, I think, in 2021. The phone that emits radiation, Motorola, OnePlus, Oppo, and Google have radiation more than one. So there is a what we call discussion among scholars about the radiations, and this is a never-ending stories about the radiation that emitted from the phones. Okay, so there are electrical fields caused by all conductors that are connected to power even with no flow of current. a current is capacitively coupled into the body where it flows to the ground electrodes. The EMF component produces eddy current in the body. The amplifier, the electrode cable, and the body form an induction loop, generate interference signal. So when actually no flow of current into the body, actually when we leave, we have a lot of electrical equipment surrounding our surrounding, and the environment itself will create the what we call as the capacitor, a stray capacitor. So actually, whether we like it or not, there will be some EMF component that produce in the body. So that's why we need to consider this in our design. Okay. Next one is the electronic device noise. So if the input amplifier gain is such that the biosignal sends the amplifier into saturation or cut-off mode, then the output amplified signal is not a true represent of the biosignals. All electronic devices are temperature sensitive, and the circuit should never be allowed to operate in the saturation or cut-off mode. So when you see the data sheet, usually when you buy a component amplifier or any analog component, you need to see the data sheet. So in the data sheet, there will be some specification of the electrodes of the components. Some are sensitive to the temperature, some are not sensitive to the temperature. But the thing is, we must use or select the suitable component so that it can operate in a normal condition without having to go to the saturation or cut-off mode. So when we have that kind of saturation or cut-off mode, when we measure our signals, then the signals does not represent a true signals from the biosignal. Remember that the basic requirement of bioamplifier is that it must not change the nature of the biosignals. Okay. Next one. Minimizing the interference requires increasing the distance between power lines and body. We need to have the isolation amplifier. We need to We need to have a separate grounding of the body at a location as far away as possible from the measuring electrodes and shielded cables, and we can use the notch filters and additional stage in the bipotensial amplifier to suppress power line interference. And so much things that we can select to minimize the interference of the signals.